Hi, good morning to all students. Assalamualaikum. So, in this topic, this is the last chapter for the solid waste management. In this topic, in this chapter, I will explain more on the remediation of groundwater. After we close the landfill, what is the important? The most important is the groundwater must be clean enough lah. There is no pollutant in the groundwater. Okay, this is the content for this chapter. First is the groundwater contamination. It's more the theoretical lah, how the contamination is occur in the groundwater. Then the groundwater remediation procedure, we follow the EPA procedure. And groundwater technology, maybe a few technology. And lastly is the treatment technology lah, okay, for the groundwater. Groundwater contamination. Traits of contamination to groundwater depend on the specific and hydrologic condition of the site. Okay, it based on the soil type. Okay, based on the pore size and everything lah. Okay, leaking chemical pass through several different hydrological zones as they migrate to the soil to the groundwater system. So this one is the hydrological zone. Okay, the upper layer is the soil actually. This one is the soil, and you can see the blue one is the groundwater. So it pass through at the several different hydrological zone, migrate to the groundwater, mostly used by the gravity lah. Okay, the pore size, the pore space in the unsaturated zone in the top soil layer are occupied by both air and water. Okay, flow in this zone for contaminant is downward by the gravity. Okay, so you can see in this layer mostly they contain air, sediment, soil, particles. Okay, so in here they have the water, groundwater. So they have a sediment, water. Sediment, I think better use the soil particle lah. Okay. The upper region of the unsaturated is important for the pollution reduction. Some chemicals are retained by absorption onto the organic material and chemically active soil particles. So that's why in the soil media they can retain the contaminants. Okay, compared to water, water will flow the contaminants, but in soil they contain the contaminant, and some are trapped in the pore space and held by a surface tension. Okay, this absorbed and trapped chemical may decompose through the ablative process such as oxidation, reduction, and hydrology. Okay, so I think the process is very complicated. So as well as microactivity, or they may simply remain soaked and trap material and carry it into the underlying aquifer for a long period of time after the source of contamination has been removed. Okay, so that's why sometimes so to remediate the soil is complicated compared to remediate of wastewater. For example, in the capillary zone, just above the saturated zone, that marks the groundwater phase between soil particles may be saturated by water rising from the water table by capillary action. It means that we have a water table. So maybe I can, okay, this is the, I'm using the blue one. Okay, water table. So it's just that to go by the gravity. Before this, I explained the contaminant will go by the gravity. So this one is the gravity lah. Okay, you know that. But in another way, the water table also can go upward by the capillary zone. Okay. So this one is the capillary zone lah. Okay. So chemicals that are lighter than the water will float, okay, on top of the water table in the zone and move a different direction. Maybe it can move, or contaminant for example can move at the right or left based on the different direction, and that dissolve the contaminants. Okay, all pore space between soil particles below the water table are saturated. Okay, so the Above water table, they are not saturated, but below the water table, they are saturated. Generally, the saturated zone is lacking of the oxygen. Okay, the lack of dissolved oxygen limits the oxidation of the chemical. Groundwater flow is laminar, It's not turbulent. Kalau compare to surface water, it's more turbulent. But for groundwater, the flow is laminar. Laminar means that they have minimal mixing occurring in the groundwater move. Okay, so when the flow is laminar, so the contaminant move in groundwater is very slower lah compared to the turbulent flow. Okay, dissolved chemical will flow with groundwater and form a distinct plumb. Okay, the shape and the size of the contaminant plumb depend upon the local hydrological setting. Okay, groundwater flow, the characteristic of the contaminants, and the geochemistry. Okay, solubility, absorption characteristic, and degradation affect the mobility. So density of the contaminant is important in determining the shape and the movement of the plumb. So this is the video that show the example of the plumb.
This animation depicts a groundwater plume from a perchloroethylene, or PCE, spill at a former dry cleaner. The transparent purple mass and black core represent PCE in soil at concentrations of 100 and 10,000 parts per billion respectively. The groundwater table, base of the aquifer, and groundwater sample locations are also shown in 3D. For a more detailed animation of the soil investigation, please view the animation referenced above. A two-dimensional representation of the PCE groundwater plume is shown next.
Okay, now we go for the procedure. Okay, how to procedure, we follow the EPA lah. First is the preliminary assessment. This is the first step lah. Okay, begins with the identification of potentially hazardous waste site. So the initial information can come from a variety of sources. Okay, for example, local citizen, state environmental agency, the site owner themselves, or simply from the awareness of potential problem as with the industry. So they have many sources of the information on the hazardous waste site. So preliminary assessment, or we call as a PA, okay, is the first step to identify the potential contamination. Okay, the primary objective of PA is to determine if there has been a release of contaminant to the environment, if there is immediate danger to the person of living or working of the worker near the site, and whether a site inspection is necessary or not. Okay, is to determine the site is hazardous or not hazardous to the environment. Okay, samples from environmental analysis are generally not taken during the PA. They just go to the site and just view what is the environment at the site. Okay, following the PA, KEP designated state agency might determine that can immediate treated residents or employee site require an immediate removal actions. So otherwise, based on PA, the site is classified by EPA into one of three following categories. So the categories first is there is no further action needed. Okay, it means that contamination occur but it's not very hazardous to the environment. Okay, so there is no action needed. Second is that additional information is required, okay, to complete the preliminary assessment. Maybe they have some dangerous to the environment. And lastly, inspection of the site is necessary. Okay, this is needed some action. Okay. So if they needed some action, so we need to do the site inspection. Okay, it's required a sampling and to determine the type of hazardous substance that present and to identify the extent of contamination and its migration. So when they have the sampling, so you know the sampling groundwater is not cheap. It is quite expensive. Okay, so the actual site inspection include preparation of work plan and on-site safety plan. Okay, site assessment have 3 objectives. So this is the 3 objectives to determine which really pose the no threat to public health. Okay, to determine if there is any immediate threat to person. Okay, and to collect data lah. Okay, whether the site should include be NPL list or not. Okay, NPL is the list of the hazardous waste site in the United States. So EPA is from the United States and eligible for long-term remedial action financed under the Federal Super Fund program lah. Okay. This is the flowchart for the federal program for cleanup of the contaminated site. So first is the PA. So if PA is not dangerous to the environment, so no release. So that's all lah. Let's stop here. If they have action, the release occur, so they have to do the site inspection. So they have to take the sampling. Okay. Then from the site inspection, they need to determine the scoring of the sites. Okay, if low score, so it's not quite dangerous lah. If high score, so it's need to be included in the NPL list. Okay, then when include the NPL list, we need to do remedial. Okay, and then you do the feasibility study, record the decision issue, remedial design, and lastly the remediation action. In the remedial design or remedial action, there are 3 types. First is the immediate removal. So immediate means to do now. Okay, it's a prompt response to prevent immediate and significant harm to human or plant removal. And lastly is the remedial response. Is intended to achieve a set solution that is permanent remedy. Okay, immediate removals are done to prevent emergency involving hazardous substance. Okay, this emergency might include fires, explosion, direct human contact, okay, with the hazardous substance. Okay, and immediate removals involve cleaning up the hazardous site to protect human health and life. Okay. This is what happened in the Johor, in the Pasir Gudang. Okay, that is called the immediate action lah. Okay, one example in Malaysia. So immediate removal response may include activities such as sampling collection, analysis, containment, okay, or control the release, removal of hazardous substance from the site, okay, provision of alternative water supply, installation of security fence, okay, evacuation of retreated citizen or general deterrent of the spread of the hazardous contaminant. Okay, the remedy scheme must minimize or eliminate the hazard to human health and environment. Okay, the important thing is human health lah. If the human health affects by the contaminant, so we need to do something lah. Okay, the technology are classified either passive or active. Okay, so passive they are without much attention. Okay, except for maintenance lah. Okay, for active system, they require considerable efforts and ongoing energy input to operate. For passive contaminant, the function is to eliminate the exposure pathway. Okay, for example, the groundwater migration, and to minimize the contaminant transport rate. So we contain the contaminant. Okay, passive contaminant control technology focus on the controlling the hydrologic for contamination migration. Okay, it means that there is no treatment on the contaminant. Okay, and this approach is termed as a containment. Okay, we call it as a containment. The selection, design, and construction of the containment technology must be recognized, each of the exposure and the transport process. If they have a surface contamination, so we use the surface water control technology, is to prevent the precipitation from transporting contaminant off-site by surface water runoff. Okay, cover surface water diversion, sedimentation, and erosion control system are employed for this purpose. Although these technologies are just one component of the overall site remediation, site condition may occasionally allow surface water control technology to be the sole means of the site remediation. Okay, the surface water control strategy integrated into site remediation scheme is depend on the other component of the remedial system. For example, the remediation program at Love Canal incorporates surface cover in the conjunction with the leachate, groundwater collection system, and treatment system. So the reduced infiltration and eliminates the problem of direct contact for previously evident. This is the example for the groundwater control. We call it as the vertical barrier. So this is the contamination in this area. So we install the vertical barrier. Okay. So subsurface vertical barrier are employed to contain the contaminant and to redirect groundwater flow. Okay. So this means we need to know the groundwater will flow at the which side. Okay. So this barrier to horizontal contaminant transport and groundwater flow used in hazardous waste measurement have developed from the conventional engineering applications such as the watering of excavation and control of groundwater flow through the beneath dams and reef. Several vertical barrier techniques are available, including slurry trench, cut-off walls, bed of soil bentoid, cement bentoid. Okay, there are many material. Okay, grout curtains. Okay, one function of vertical barrier wall is to provide containment to prevent migration of contaminant. Vertical barrier also provide groundwater control during the construction and control horizontal groundwater flow. Okay, the most common configuration is fertile, where the cut off of walls around the waist of the waist side are shown in figure 7. Okay, this is the from the book. Okay, from the extra note they are giving to you. Okay, so vertical barrier walls may also be located up gradient or down gradient. Okay, of the side depending on the intended function of the barrier. Beside the vertical, we also have the horizontal. This one is the horizontal barrier. Okay, the subsurface are employed to contain contaminants and to redirect groundwater flow. Okay, can be categorized by the installation requirement. There are those that cannot construct in situ. Okay, construct in situ means that a barrier may be constructed beneath an existing waste site or contaminant plant. Okay, most horizontal barrier must be constructed prior to the placement of the overlay waste or contaminants. This horizontal barrier was developed from a conventional groundwater control applications such as canal, dam. Okay. Before this I explained on the passive. Okay, now we go to for the active remediation system. The system require ongoing energy input and includes such as a pump and treat, electrokinetic, in situ biotreatment, and soil washing. Okay, they have many. So the objective of pump and treat system include hydraulic containment of the contaminated groundwater, removal of chemical mass of the groundwater. Okay. For the remediation of the groundwater contaminated with the volatile organics. Okay, what is the volatile organics? Is the micropollutant. Okay. In situ aspaging may be considered as alternate to pump and treat. Okay. So the contaminants is usually too volatile. They use air spudging. Okay. The concept of spudging involves the injection of air into the subsurface to increase transfer of volatile organic from the aqueous phase to the vapor phase. Okay, this is the one of the treatment lah. So the air, the injection well, so they go here, and the contaminants we volatile go to the vapor phase lah. Okay. For the in situ biotreatment, biotreatment means they use a microorganism to take the treatment. Here they inoculate the microorganism into the water, then they pump lah inside the soil, okay, to treat the groundwater. Okay, inactive remediation system. Okay, a drain tile collection system is constructed by excavating a continuous drain in the subsurface and installing collection piping and filter media. This is one example. They construct a drain tile collection. Love canal is the best known use of drain tile collection. Okay, so the purpose of installation drain collection in subsurface the system can be used as an intersected trench. Contaminants flowing the groundwater are intercepted by the trench. And for the immigration, the system can be used as hydraulic barrier. Okay. And cancer means groundwater and contaminant extraction, parametric lah. Okay, the system can serve to capture a plump that may have already migrated beyond the collection system. System can function effectively in geological units that have insufficient saturated thickness for the use of extraction well. So the biopolymer cycling is a construction technique whereby continuous subsurface drain can be installed relatively rapidly, safely, and cost effectively. Okay, the technique books as on long known and employs slurry trench method to install the subsurface drain.